Hello, how's it going there? If you're watching on the stream, if you're watching afterwards, thank you for joining me today. It is August 1st, Monday, the year of 2022, and we're going to do some live coding today. I hope you're excited to join me. Doing these live streams for a little bit now. It's been about 7 or 8 months, and I'm going to start posting them on YouTube too. So hopefully this stream will also go up on YouTube. So it's uncut here. We don't take any time to stop. We just keep going, chat with chat, hang out. You should join one of the live streams sometime. And with that, let's check to make sure the chat is working. Sometimes it takes a little bit of time for people to join us because there's a little delay. And not only that, they make people watch advertisements a little bit. And Odinson is here, yes. Without fail, what's up? How are you doing? How's your day so far? Or morning. It's a morning where you are, right? So let's switch this up a little bit and go over here into dual cam. Should I do 1 or 2? Here we go. So I've been looking at this new competition that was just released on Kaggle. And I was thinking it'd be kind of fun to take a look at. What do you think? What do you think, Odinson? You just woke up 1 hour ago? Nice. Okay. It is time to check out this new competition. I think it's the only one that has been released lately. So if I look at all competitions, oh, there's a new Tabular Playground series because it's August 1st. August 1st, 2021. Man, time flies. We have the Shootout one that was just released. It's only 2 months long. That's kind of short. I think I missed this one. So there's another RSNA. So this is like medical imaging. There's a Mayo Clinic one that's also medical imaging. This one maybe I haven't looked at, the RSNA. Cervical spine fracture detection. When did this one launch? Let's look at the... not the leaderboard, the overview. 4 days ago. So I definitely missed the launch of this one. Cervical spine fracture detection. Do you know, just a little bit of little trivia, I don't know, little background. I had my neck, my spine, C7, C8, I think fused. I have a scar right here. If you look at it, I have a scar. And they went in and they took out everything in there and they've fused it together. So if you saw my spine imaging, you would see a bunch of metal in there. Let's agree and understand this. Let's look at the training image. This could be a fun competition. Oh, they're DCM files, so it's not going to render here. But I'm sure someone's made a notebook where you can see it. So DCM files, does that mean this is 3D? Because it's an MR. Yes, it is. That's pretty cool. How big is this data? The data size is too large. One with fracture detection is also new. Oh, Odinson, you're 1 step ahead of me. Oh, so they're looking at these high C. Oh man, I should go get my scan of my spine and see if I can add it to this competition. Maybe I can augment the data. Should I ask about that in the discussion forum? If I can add in my my spine imaging to this? There will be 8 rows per image ID. This is pretty cool. This is cool. Yeah, I had to do a bunch of MRIs when I had that happen. And you said the data size is too large. Let's look at this. Oh, whoa, 343 gigs. That is large. That's no joke. I wonder if it can be down sampled. Each of these, so each train image, I thought we saw some DCM. Oh, I remember this. So I've worked on 3D imaging before in the competition that involved brain, fMRI, I think it was fMRI data. And what each of these DCM files is like essentially a slice of the person's vertebrae. So it's like an image 3D looking through the person's spine. And in the one with brains, it was like a slice of the person's brain. So you can kind of put them together, and the resolution isn't so great that you could like look across of the slices and make out that much. But yeah, each of the individual images is pretty detailed from what I remember from the fMRI. Let's see if anyone's notebook actually shows that. Yeah, so this looks like the different slice, right? Raw pixel array distributions. Okay. So I was thinking about looking at this one though. The Bundesliga Data Shootout. Data Shootout. So the data is video. It's 37 gigabytes, so it's like a tenth of the size of the fMRI. It's not fMRI. Is the cervical spine one fMRI? These are just CT scans. So a tenth of the data in size. It consists of video from different football matches, what you all call football, what most people call football. And we're trying to detect when events occur. So one thing I've already thought about is making an additional data set for this that already has the data sliced. And then another idea I've had for this is using something like Deep Sort on it. So these are some of the ideas I had. We can jump into it. I've already downloaded this data here. Okay, so let's go here. Oh, why isn't it letting me? All right, so I'm going to go into my repos directory, and then I've made this data shootout repo. Let's make sure this is sized correctly. So in this data shootout repo, I have our input data. I guess I can delete this zip file. And we have the DFL data shootout. And maybe we can explore this data a little bit. So I haven't even done much exploring. Let us go to the correct directory, which is basically where this is, show in file browser. And let's start with some EDA. I also want to understand the evaluation metric better than I have, which is like I have no idea what the evaluation metric is, other than I saw that they have a notebook about it. Hey, MGX, what's up? Were you streaming the other day, hey, MGX? I think I might have seen you playing Pokemon. That's awesome. Shout out to Hey, MGX. I am streaming on a Monday. Usually I'm streaming on Sundays, Tuesdays, and Thursdays, but this summer it's been I've been taking my time. You were streaming last night, had a blast. Nice, that's fun. I only got to catch a little bit of it, but it looked like you were having fun. All right, so we need to learn this evaluation metric. Submissions are evaluated on the average precision of detected events, average over timestamp error thresholds. So I think we're given timestamps of when events occur. There are 3 of them: challenge, play, and throw in. And then they give us the start and the end of each of these events. So I'm guessing it's average precision is just average precision summarizes a precision recall curve as the weighted mean of the precisions achieved at each threshold, with the increase in recall from the previous threshold used as the weight. Where PN and RN are the precision and recall at the nth threshold. So what are the different thresholds that it goes over? Let's go over the event, the metric. Okay, so that's what they're giving us here. The error tolerances in seconds for each classes are. So okay, so this is interesting. The more on the nose you are, the better you're going to be. I think there's another competition that involved this with these different thresholds. So they're just going to average across these different thresholding, and you're going to be penalized if you, if you're really confident of an event, you're going to have a high weighting for it. I wonder why the weights for play and throw in are so low and challenge are so high relatively. Does that mean that you like predict on different scales? It's my low stress stream game. It's a different vibe when I'm playing Age of Empires. I've never played Age of Empires or Pokemon other than Pokemon Go. So I'll have to take your word for it. Although I have been really getting into Elden Ring lately. I finally got past the point in Elden Ring where I wasn't just dying every 5 seconds. Now I'm dying like every 5 minutes. So that's a little bit more fun. Yeah, this is a super simple metric, right? Jeez. This is super simple. I'm just kidding though. Okay, so they're taking out the start and the end. So really the start and the end don't matter. Okay, so let's basically do EDA of, what's this competition called? Shootout, Data Shootout. Import pandas, import NumPy. By the way, if you're just joining us, I'm checking out this competition, which was just released this week. And I'm going to show you guys some cool stuff today, so make sure you stick around. Hey, Clipped 9M, you resubscribed for 1 month at tier 1. Thank you for subscribing for 4 months. That's awesome, man. I appreciate it. Should I spin the wheel for you? I mean, that's kind of our thing. We spin this wheel whenever I get a new subscriber. Clipped, thank you for being here. All the time. Let's go. 10 push-ups. Cheers to you, Clipped. Clipped's getting us rolling tonight, early on. Hey, Marcos, thank you for following. Hope you're having a good night. I am. I'm looking at this data set. So, all right, let's look at our training data. Our training CSV looks like this. I think the event attributes can be ignored. Well, I guess they might be useful for training. So each video ID, I think from what I read before, is a half of a soccer game. So first, let's look at the number of events per video. So this video ID has the most events, 1606. Let's go into our data. Let's open this directory and then let's find that bad boy. There it is. MGX's hype. So this video is 56 minutes long. For reference, it's the one with the most events. And let's see, is the first half in here? No, I don't see it. I don't think there is a test data frame. However, I think there is there are test videos, but these are small, right? So if we open up another tab here and go into train, these are 2.5 gigabytes, around 2.5 gigabytes. I think these test ones are just giving us examples for reference of what will be in the test. I don't know for sure if this will be in the, so if we grep on this with, LC grep this video name. Yeah, it's not in there. It's not in there. So maybe I can read about that in the data section. I need to be more patient, but whatever. Okay, so the training data, we have more events in this top video. The least amount of events is this video. Let's go to VLC. Least amount of events is in this. I have no idea if that's because of the game itself or if that's just, just how the game goes. If it was a close game, if it wasn't a close. Have you ever won a Kaggle competition? Ivan, what do you define as won? I've never gotten first place in a Kaggle competition, no. You can check out my profile by doing !Kaggle. You can see all the competitions I've been in. Watch it not work now. Okay, so it's not going to work. Maybe I was wrong. So I'll just paste that here. I've been in all these competitions. And the best I've gotten is second place. And the best solo effort that I had, I was in... It was... Shoot, where is it? This one. I was in second place this whole competition. I was in first for a lot of it, and then I dropped into 11th spot. So, was it an event? Does it include the practice at the start of the first clip you showed? Yeah, it looks like they just dump the raw video. So going back to this video, They just like start a camera at the beginning of the game, and it does have an operator, like it's moving around during the game. But it doesn't stop. It doesn't look like it's a continuous video throughout the entire game. I guess that's how soccer is anyway, right? Shows how much I know about this sport. I know it's a beautiful sport. I'm just saying, I don't know as much about it. Showing my ignorance. Okay, so let's look at group by video ID, right? Events. Event dot value counts. Now, do I want to unstack this? I do want to unstack. What does this tell us? This tells us for each game, how many of these events occur. We're also going to query where event not in start or end, right? Because that is not actually an event. The start and end is just telling us how long the event's had. What's the question about the game? The question, there is no question. There's an objective, Marcos, but I do appreciate you asking. The objective is to create a computer vision system capable of determining when these events occur. So we're gonna look at some of them. It's not gonna make much sense yet, but it looks like there are a lot of between. Let's do this. Sort values by play. There's between 232 and 434 plays in a half, because each of this video is a half of a game. There are between 38 and 60 in challenges. And then the throw, or I guess I'm not sure exactly if that's how many challenges there are. It does look like the highest and lowest number. Nope, here's a 70. And throw-ins look like they're in the low 20s, high teens. What's the question about the game? Okay, so my question about the game football is, here's some questions for you, Marcos. Does the game ever stop? Are there stoppage of plays in the middle of a game in which, oh look, they scored here. Is there a stoppage in play in which the play stops and there's a commercial break? Oh, there are 3 stops. Okay. Yeah, look at and there's injuries, I guess. People like, aren't there a lot of flops in football like this? Where players will get injured. So I guess those are stoppages. But we're gonna figure out what a play means. So what is a play? Can you define that for me? Because there's no like obvious start. We call 3 tempos. Okay, gotcha. So I kind of wish there was a format of this where it said challenge, and then it said challenge start time, challenge event time, and challenge end time. Does that make sense? Like for this video, it's actually, and also these are times. So we need to know the frames per second of the video in order to convert these times into frames, because we don't really care about time, we care about frame. Maybe if we take the time and we take frames per second, I'm guessing is like 30 frames per second. Hey, we got a follower, Blinderson. Welcome to the family. I hope you're doing well tonight. We're just looking at this new competition. So it doesn't look like these are evenly divisible. So I don't know how they got these timestamps. All right, so we're gonna loop through these videos. Nachola, what's up? Welcome. Let's take an example video from the training data set. Would it be helpful to show this in a bar plot? Let's do title event count per video, right? Did I import matplotlib? Not yet. Boy. Okay, there we go. Now we are going to take this training data set and we're going to loop through it for a video ID. So let's query video ID equals this. Oh, I need to put this in quotes. I don't like the way they set up this data. I don't like it's time start and end. Like I said, I want it to be pivoted almost, but I don't have a unique value. Now here's a question. Are they always going to be, yeah, they're always going to be in a row, right? So basically I can take the index and I can divide it by 3. And this is going to be our event ID. Ah, look at this. This is nifty. That's our event ID. Then if we group by video ID, event ID, unstack. No, this isn't going to work. I think I can do group by event ID. Let's just try as an example time. No, event. Yeah, this kind of gets it in the way I want it. This gets it into the way I want it. So this is a challenge. The first one is event ID 0. The challenge is at 201, but it starts at 200. It ends at 202. Hey, con muchas ganas. Welcome to the stream. I changed the angle of my camera. I hope this, I haven't looked at it much recently. Yeah, so exclamation point competition is going to bring you to an old Kaggle competition that we were running. And also, so you might not want to click on that. Are there any video IDs with multiple challenges? Not, so the way I did this, hey, NY Thurino, welcome to the family. The way I did this, it will not make multiple challenges. I'm going on the assumption that it's always start, event, end, start, event, end. And the event can change. It can be a challenge. It can be a throw in. It looks like. But okay, so here we go. Now we need to start looping through the video. Now we need to start taking this video ID and forget about the idea that I had before about pivoting stuff. But let's actually find the time equals 200 of this video. By the way, I'm going to show you guys some really cool stuff that I can run on this that I've already figured out. We're going to look at this in a few seconds, so do not go anywhere. If you are planning on leaving, you're going to miss out on some fun. Nice competition. Need to learn about music. Oh yeah, that competition is... Which is the goal? NY Therino, you need to tell me. Okay, the goal is to take this video data and to tag it automatically with the events. Ivan, welcome to the family. Thank you for following. I appreciate it. So this is the first video. Let's go to second number 200. 200 is 2 minutes. Oh, geez. See how bad I am at math. 200 equals 60 times 2. 2 minutes and 80, nope, 3 minutes and 20 seconds. So in this, the first event is 3 minutes and 20 seconds in. So they kick the ball around. So this is the first event. It's a challenge, ball action forced. What does that mean? Then there's a throw-in, right? I'm so confused already. Let's see. I'm on the right video, right? 1606. There is a start. There's a challenge at 201. A challenge in sports I'm used to watching is like the coach is challenging that something happened. They go to video review. So I don't know what this challenge is all about. So right here at this time, there's a challenge of a ball action forced. That's like when they head the ball. Then at 210, which I think, isn't there a throw in there? What? Let's make sure we query video ID equals this. Maybe I'm missing some events because I'm just assuming this is sorted. Query video ID is that, and then we're going to sort values on the time. No, that's the okay. So there is a throw in. It says at 12. At 2:19. But 2:19 would be 3 minutes and 39 seconds. Okay, so I'm already confused. The man Opic, welcome to the family. Thank you for following. I appreciate it. I appreciate that you're here. I know that the camera is kind of in a weird angle, so maybe I'll move it back, but okay, explain this to me, you soccer/football people. How is this not a throw-in right here at 3 minutes and 20 seconds, 27 seconds, which would be in between this challenge and this challenge, I think. Oh no, this says... This is a throw-in, right? But then the ball comes back out. And now there's another throw-in at 3:35. So that's this one that's tagged. So they missed a throw-in. That's all I can think of, unless I'm completely missing something. So already I'm confused. Yeah, 2 throw-ins. I know that like legally it's okay, but let's look at the data here. Let's look at this data. This is the data they provide us for this game. They say that first thing that happens is a ball action forced. Okay. Then there's a challenge, which is a opponent dispossessed. Then there's a throw in. Then there's a pass. Then there's another pass. So they definitely don't have two throw-ins here. So they're missing one in this data label. Let's read about the data. Oh, I didn't realize this competition is two-stage. So video ID identifies which video occurred in. Event is the type of event occurrence. Also present are labels start and end, indicating the scoring intervals of the video. See the evaluation page for information about the scoring intervals. Scoring intervals are not provided for the test set videos. Whoa! So they're going to pick different scoring intervals for the test? They're going to play some funny business with those numbers if they can just pick any numbers for the scoring. That's a little bit sus. Event attributes are just extra data. Okay, so what we're going to do is we're going to loop through this video. We're going to import CV2. And that's not going to work. Why not? Whoa, this is a new one. Did I accidentally install two CV2s? They're saying to downgrade OpenCV. I can do that. Probably should have looked at what version OpenCV I had already. Okay, that was quick. I uninstalled 4.5.1. Oh, well, I'm actually upgrading. Let's reset this. Let's try to import CV2. And it works now. Okay, so what have we done? We've seen how many events are usually in each video. We've tried to figure out the frames per second, but we can figure that out soon. We're wondering why they gave us timestamps instead of frames. We're going to create a capture device, a video capture device with this training data, not the CSV, with this first file. Did they give us both the halves for this? They do, the first and the second half. So we're going to start with the first half. And this is going to be our capture device. So it's going to return an image every time we do read. Return's going to be true, and the image is going to be this NumPy array, which is our image. Hey, if you want to learn more about this stuff, ! YouTube. I have a whole video that no one likes and no one watches about how to work with video data. You won't see it at the top of my most watched videos because no one watches it. I think it's a good one. It's this one, working with video data. I'm going to go ahead and put this in the chat. Boom. Okay, so if we do I am show, we're just going to make a matplotlib plot of this, and we'll do, I've done this too many times to know. All right, so this just shows our image, but with inverted colors. So we're going to do CV2 convert color from, by the way, let me know if you guys can't read. Road to 10K. Yes, for sure. Color. Hey, Thrain, thank you for joining the family. You are part of the family now. What is it? Color convert? I always forget it. Someone help me out. I was on a roll. Maybe because it's... That's why. BGR. Thank you for following Yu. Oh, jeez. BGR. Oh, there it is. Color BGR to RGB. Okay, finally we got there. So this is the first image. This is frame. What is this? Oh. Eyes. Thrain. You're just watching us hang out. Yu's got my back. Thank you, Yu. I figured out before I saw the chat, but I still give you all the credit. Okay, so I still think we need to do 60 frames per second, and we need to take train time. Right? If our frames per second is 60, so let's do FPS, which we've already defined above as 60. No, I made it 60. Then I started doing this. So this is the frame. Right? This is our frame. We've added that there. Let's do cap.release at the end of this. So we are always releasing this video capture device. And what we're going to do is one other thing we can do with cap is CV2. We can get the frame rate. I gotta learn how to type. Find frame rate. Of course I look this stuff up every time. Cap prop FPS. Cap.get, and then we do CV2 cap prop FPS, and it says 0. That means it's not in the metadata, I think. Yeah, so let's assume 60. Will Thurl, I did not say that. I thought it would be in commands, but could someone catch me up with what we're working on? So Chrissy Codes, I like your name. This new Kaggle competition was released with this, I'm putting it in the chat. It has a bunch of video data of sports, of soccer, aka football, for you non-American folk. And I'm trying to figure out how to pull out. Oh, Kaggle, heck yes. Yeah, look at this. I got my Kaggle shirt on. I'm representing. Okay, so can we at least get get CV2 max frame? Gigaframe sends high. No. CV2 get video length. I don't know. Here it is. Cap frame count. Yeah, that's also it's also non-existent. Thank you, metadata. Let's just make this number really large. If the last thing we're going to do is read the next frame, and if ret is false, we'll break out. And then we are going to, should we just take the frame and round it? I'm doing this all wrong. This is times 60. That makes a little bit more sense. That makes a lot more sense. Okay, so train time. Why didn't any of you guys tell me that before? So this is our frame. It's still not a round number. Probably because it's like 59.95 or something, isn't? But let's just say 60 and hope it's okay to start with. We'll figure out the frame rate later. And let's do round. As type int frame rounded, right? Got a frame round. Oh, undo that. Escape Z. Now I did not want to run this cell, and I did. So I need to kill that. Let's do cap release. And we're going to get little clips. We're going to get little clips of each event. Should we make them into videos? Good evening, Data Basics. How are you doing? Welcome. So we basically want to take the training data set. Didn't mean for that. Okay, so we'll break this out. Oh, let's do something else too. Let's do import from tqdm import trange and import tqdm. And I need a spell, right? So let's make this trange, and let's also make this train query video ID equals at video ID frame round max. So this is going to take the max frame. It's going to loop over I don't know what I'm doing here on the bottom. It's not supposed to do that. Okay. Just to make it more readable, this is gonna, let's call this max event frame. So it's going to start at frame 0, go to the max event frame. If it gets no results, it'll break. It should never do this because it should be able to get to the last frame. Then it's going to pull the data from this frame. Then what we need to do, yeah, let's just create some video clips, right? So then if the length of frame data is 0, continue. Basically, if the length of frame data is not 0, then we're going to do something. If the length of frame data is not 0, here we're going to, one, if it's start, make a video clip. Otherwise, append the clip. And 3, if it's the end of the clip, close it. Yeah, I need to, oh yeah, I'm missing the if. Thank you. So if the frame data, let's break out here and not break here so we can do this legitimately. So it's going to go, it did not break. Let's just make sure it actually gets into there. Is it because I'm not incrementing the frame? So let's look at this. Oh, it's because I'm thinking about seconds, but the train. So the minimum frame is 120. Yeah, 12,000. So it's going to have to get to 12,000 before it even pulls anything in. So it should get to 12,000 break. And it doesn't even do that. Oh, 12,000. Yeah, it hasn't even gotten to 12,000. This will take 14 minutes to run through. Okay. So while that's running, I'm going to take the frame data. So if the event is start, then we're going to pull out, I'm going to move this. There we go. This way I feel like I'm looking at you all. Okay, so let's see if it gets to 12,000 and then breaks. I don't know why I'm testing this. Maybe so I have a second to think. All right, so if the event equals start, then we're going to create a new video. Yeah, so it goes in here, then it breaks. All right, so if the start is that, then we're going to do right equals CV2 video writer. The writer is going to make it into an hello. Boz Lucas, we are making video clips. We're working on this Kaggle competition. Tell me when you guys think this is too much and I'll show you the super cool thing. I can stop this and we can talk about the super cool thing. But if the frame data event equals start, which it should here, print frame data. Oh yeah, this needs to be values 0. Hello, Danielson. Is that like Danielson? Or is it Daniel Ussen? Welcome to the family. How are you doing? Oh, I shouldn't have done values. I'll do it here. Frame event values equals start. Then it's going to print the frame data. Then, okay, so let's just think this through. It's in there. If frame data event equals start, then it's going to create a writer, which is the frame data event ID. By the way, did we make sure that event ID was a integer? We did. Event ID will be this. We already have the video ID. So then we're going to write out of something that's going to be the video ID and then the event ID. Should we put the event name? Oh, you looked up the codec and it says 25 frame per second? Maybe that'll explain why I was so thrown off. Okay, so let's do this math again. Thank you, Octavus. Let's do this again and see if this makes more sense by watching this video. So, we actually have this frame column now, which we can redo with a frame of 25 frame per second. Are these round numbers? No, they're not. It would be nice if they were round numbers because then I know I'd be more confident that it's correct. But let's look at... no, because this still is the timestamp. It doesn't really affect anything with the frame per second change. Man, I was excited there for a second. Okay, so let's check your hypothesis or what you're saying. Let this. Oh yeah, this needs to be indented. Hey, Frossetto, welcome to the family. How are you doing? Welcome. How did you find the channel? Let me know. So now this should get to frame number 5,000 before stopping. I really hope it's 25 frames per second. Actually, we can just do the math, right? If it's max event frame is in frame 5, whatever, times 25. Actually, let's just go to train query video ID equals at video ID. No, we can't figure it out this way. All right, so we have the event ID, max event frame is that. What we need to do is look at the image here. I already did this plot earlier. Shoot, am I gonna have to do it again? There we go. This color is capital. And there we go. Okay, so does this look like... Yes, this does look like the first event. I think you're right, Octavus. Thank you. Did they talk about it in the data? Frame. They don't talk about frame anywhere. Discussion. Frame. Someone's already done this. Oh, someone's already created data sets. To get started, I extracted the frames from the videos and resized. Okay, so these are just smaller videos. Not quite sure what's going on here. I also mapped the events, play challenge, throw in to the corresponding frames in this notebook. Hey, thanks for following DJ Almazocruz Jr. If extract frames. But you can't get the frames per second, at least not with the one I tried. He's trying to do that. Create the video folders. This is just resizing as JPEGs. All right, so what is this person doing? They're filtering the data set by the video to make sure use of the timestamp of each video and avoid conflict. Where's FPS? It's only taken in from the vidcap.get, which was not working for me. Was it not working for me because I closed? Because I did a cap release? Let's try this. Let's just see what this guy did and make sure it's... Okay, so it's 25 here. So it worked. That could have been my issue before. So it truly is 25. We tried this before, but I think I had already released the cap. So I think if we do now the same thing, it's going to be 0. Maybe that was part of our problem. Yeah. So that's on me. That's on me. I still think what we need to do is create like little video clips of each event. Hey, thanks for following Madmaha One Kawi. Welcome to the family. Let's see if we can create one video clip. We'd have to compress. What time is it? 10 o'clock? I think it's about time. It's been an hour in. I could show you some of the cool stuff I was working on. I don't know if this is actually going to help on this competition. But I was working a little bit on this right before I started. So we all know YOLO v5. Maybe we don't. YOLO v5 is like... helps us to automatically detect objects. Luckily, it's pre-trained on people, right? So if I go into Conda activate YOLO v5, I could take, and it's nice to run this on some of these little clips. They give us, not only did they give us train and test videos, but they give us clips, which are just like small clips of a game without any labels. But we can at least validate that the YOLO v5 can work on these, right? So if I go into YOLO v5, then I do, let's also see which GPU that I'm using right now. It looks like GPU 2 is being used for my streaming stuff, so maybe I'll use GPU 1. It looks like GPU 2 has the most. So I've already run this. Let's just do the base weights. And let's do help on this so I remember. This is going to be cool, guys. So we want the source to be the repos directory. Kaggle, Data Shootout, input, and then the clips. And let's list all these. All right, so clips 2E57B91. Let's see what this looks like. Oh yeah, we want to also display. Show dash image, I think. Maybe it's an underscore. Where is it here? View image. View image. Jigaman, what's up? Welcome to the stream. I hope you're doing well tonight. All right, we see people. We see people in this video. It's detecting persons of interest. It's detecting people. This is going to get cooler too. What I'm showing you right now is going to get even cooler. Right? So we've detected people in the video. Luckily, right now, it's not detecting any of the people here on the sideline. I guess we're just getting lucky with that. It's not detecting anyone here in the crowd. But we can change that, right? Let's pick another video too. Let's pick 538, one of these 538ers, 6. We need something to detect the ball. Okay, so it actually will detect the ball. Oh, this is doing an old one. View image. It will detect the ball because that is one of the targets that it could detect. Oh, look, there's smoke in there. So now it's detecting people on the sideline. It'll sometimes detect the ball. See? Oh, why does it call it a person? It did there for a second. You might have seen it if you were looking really close. It said sports ball because that's one of the labels that it's trained on. But it's actually pretty hard for it to catch the ball most of the time. It shouldn't be as hard as it is, right? That's pretty cool, right? Let's just find another video just to make sure we know what we're doing. 7.4. Let's start with the 0 one. So you do a lot of machine learning? Yeah, I do machine learning. I like machine learning. All right, so we're seeing that it's missing this person in the top left. Let's just change the minimum confidence to 0.1. Let's lower it. I think it's 0. Conf thresh. I don't know what it's by default, but we'll see. Seems like it would use a lot of CPU power. It's actually going to use a lot of GPU power. See, look, this is my GPU. It's a 1080 Ti, and it's running in the background. And it's detecting, I think that's an umbrella. I've lowered the threshold. Now it's going to show more images. Like it's going to start detecting this top right as being a TV when it's really not. It detects this as being a chair. But we've purposely done that. Also, let's do this. So when we were running this, it was taking about 0.006 seconds per frame. Let's use different weights. Let's use the latest weights. The extra large weight. F to fix. Well, welcome to the family. I hope you're doing well. I need 2 dashes here. New here. Is it YOLO? It is. YOLO it is. But I'm going to show you something even cooler here in a second. So F to fix. Do not leave. You're gonna like this. So this is a larger model. It's more accurate. It's not taking 0.00 whatever seconds. Now it's taking 0.02, about 0.03 per frame. So it's slower, but it's more accurate. Can this work on live video? Heck yeah. Look at this. I've done this before. Almost want to make this into a... Let's see if I screw up my stream by doing this. I don't want to do my... See, I could do my live video and we could see... You're learning computer vision for fun. You're in the right spot. So, Jigaman, I want to do this live, but I'm afraid I'm going to mess up my stream. So I'm just going to show you this video where I do it on a webcam like this. See? It works fine on a person. It thinks my glasses are a tennis racket, so it's not perfect. So I'm not going to actually do that. So we have the large weights, right? Now there is, now there's something called... deep sort that I'm going to show you. So that's this. Now I've actually created a YOLO, a test video script here, so I don't have to write that out every time. Let's put this on the right side. So this is like, I was messing with different confidence intervals on some of these test videos. But what deep sort does is, I'm going to have to kinda activate deep sort on this right side. So now I'm in my deep sort environment. So what this does is this not only does object detection, but it tries to track each player or each object across frames. Watch this not work. Oh, wait. I've already ruined it. Hold on. I don't want to show you too much. So let's open up this main. This is the main code that runs this. Probably make this a little smaller. I wrote my own little special function up here earlier that's called crop field, but we're not going to look at that yet. So let's run this without crop field on. I added it as a command line variable. Oh, nope. Don't want to do that. All right, so do this. And let's run this test video. Hey, Adalicio, welcome to the family. I'm so glad to have you here. I hope you're doing well. So now we see what it's trying to do. Oh, I think in order to speed it up, I was trying to change this frame interval, but let's go ahead and make this 1. I could also make this image size like very large. And it'll be slower also. So it's just we're sacrificing speed. Hey, welcome to the family. Who we got here? Reg 9K, welcome. So you can see it's running pretty slow here, but it's actually tracking each player across frames. So look at number 1 here. It's found the person and then it'll start to have issues. Oh, look, it actually detected the ball there for a second. It'll have issues when players go in front of each. So this will be an interesting thing to run on these smaller clips that we generate. So maybe to make this run faster, I will reduce the image size back to 640. Wow, that's new. You pronounce my name right. Cheers. Oh, nice. I just tried. I tried my best. I'm glad I got your name right. Don't you need a high resolution video file? Question mark, question mark. I mean, what do you mean by need? Like eventually it'll be preferable to have as high of resolution as we can to get as accurate as predictions to win the competition. But at this point, I'm just trying to show you guys what's up. Oh, also welcome from Brazil. I got a lot of fans from Brazil. Let's look at our geospatial. Yeah, you're the only Brazilian right now. Got 11 from the US. What's up, Guadalupe? We got 1 from India. I think that's Odinson, unless Odinson's left. Welcome everyone from all around the world. Humbled, that's why I love them. So we got people and we're tracking the people across frames. This is pretty cool. And this is something we could maybe feed into another model to try to detect what's going on, right? We could also try to detect, I feel like the ball detection is not very good. For the win, Brazilian talking from USA. Nice. Do I perform manual labeling a lot? What's my go-to tool for that? We've tried to do a little manually labeling on the stream, but most of the time I'm working with pre-label data or like working with AWS or something. Hashi, welcome to the family. How are you doing tonight? I hope you're doing well. Thanks for joining. Okay, so here is the thing that I wanted to show you too. I just figure a machine would want high res video for high reliability. You're correct. I'm just downgrading the resolution for the upgrade in speed. As you can tell, it's already pretty slow here. The fans on my GPU are spinning right now. Whoa, look, it tried to make 2 people out of 1. So this example is actually not very good for showing the sideline. So let's look at this. Let's do EC 783 A6. Sounds about good. Let's hope we get one where the video shows a lot of sideline people. What are you using besides Python to obtain this result? So this is Python using OpenCV and Deep Sort and YOLO. So that's built upon a bunch of C libraries and other libraries. OpenCV is, I think, all C. Welcome to the family, Somebeast X. Welcome. How's it going? So again, I have another video where it doesn't really show much of the sideline because I want to really show off my my results. So I need a good example. CD 9876 C5. Yeah, let's do this. Right? Hey, this is Bundesliga. I need to learn how to say that. Bundesliga competition for Kaggle. Correct. That's what this is. That's what this is. All right, this is a good example. Now we have all the crowd. It's detecting people in the crowd. Now this is a little bit of a problem, right? We'd prefer not to detect people in the crowd. So, still in the works, but I edited this a little bit to try to identify just the field location. And I could show you how this looks here. Yeah, so I found this, like, these functions where you can actually take the image, and this is how it works to my understanding, this crop field function. So we take this image. I added this dilation because I felt like it helped it out a little bit, but then I convert it from BGR to HSV. So then we have the value, which is just a color range. We know that the color range of green for the V value is between 100 and 180. Now this is something that might need to be tweaked per video. But then what it does is it finds a contour that kind of takes in all of the field, because the field is all green and the rest is not. Wish I had an example where I printed out each of the steps. Let's just do that. So let's step through this. We have our image. Maybe it's not worth stepping through. Maybe that's too boring. This is our base image. Of course, we want to convert this to where's one of my plots here? We want to do it like this. Let's make a little function here that can plot this. So we have our image that looks like this. Then we have our threshold and our contours. Then we're going to draw the contours on this marked. So I make a threshold where this is like the area of the contour has to be at least this big or else it doesn't count it. And then I'm going to show you this marked version. It doesn't look marked though. So hopefully it works on this one. Then I take out the contours and I make a mask. Let's show the mask. That's the problem. The contours does not show the mask. So maybe this is too large. Let's do 500,000. There we go. Now we have a contour. So that this also needs to be tweaked. These are going to be a problem. This is trying to find like where the field exists in this. So at a certain point, maybe I just need to take the largest area contour and have that be it. But at a certain point, it's just going to not grab anything. Oh, I know what's the problem. Is I want to make this threshold 200. I think that's the problem. Is the threshold needs to be bigger. There we go. Now it's kind of showing it's grabbing a little bit more than the field, and it's actually not getting this really dark area in the side. But let's just ignore that, and let's show what the mask looks like. So the mask is just like blacking out everything that's not in here. So this will take care of all these sideline people that we saw in our example before by just blacking them out. And then we'll show what our masked image looks like. Right? This is what they look like. It looks like with it removed. So hopefully this can be helpful for us to remove the sideline people. Now going back to this, I'm going to show you how I added this just as a argument to this script. So if you call crop field, then it will crop to the green field. Right? And now let's run it. Maybe some dilation. Yeah, there's a lot. Like what I was just kind of experimenting with this, and I noticed like different fields have different greenness of the field. All right, so this is not working at all. Let's make sure in here. What's my threshold? Maybe this is why. Maybe it's just loading. Man, all that buildup and now it's not actually working. Is it because I changed this video? Yeah, let's just use this video as an example and make sure it works in our other notebook. Where's that here? All right, so we're gonna pull this in as an example. This one. This is our video capture device. We're gonna read it in, plot the image. All right, it's kind of dark in this one. That's the problem. I think I need to make this threshold even higher because it's not gonna show anything in the marked area. Yes, so this needs to be like 230, 250. Let's make this threshold up here. $120, $250. Huh. So it's like too dark. It's too dark for this to work. Maybe I just need to go back to this one to show this example. This is the same game though. Okay, so now this is working because it's a brighter field. So I don't know, maybe it won't work if it's a dark field, because then the contrast between the field and the sideline won't be able to remove it. And here it doesn't even work perfectly. But what we do see here is we don't have the problem of it detecting people in the bottom half. Now clearly this needs a lot of work, but at least shows you with like an hour of prep work, some of the ideas we can start to implement. So a few things I've been thinking about doing. One is creating a data set with just the clips. Oh, look, it picked up the ball there for a second. A data set with just the clips of each event. And then you could train a model just on those clips. The second idea would be to actually extract all this data out for the training data set with either with or without the deep sort added to it. And then that's just like XY coordinates. So let me show you what that looks like. And then provide that data set that we could also use on the test set. So I think I have this. Yeah, so this is just the result of YOLO v5, and it has the X, the Y, and I actually think this is X1, Y1, Y2, or X2, Y2. I'm not sure if it's height or width. I just added these column names because I wasn't sure. But yeah, this gives us each of the locations, and then you could have like a graph neural network that just looks at where the players are relative to each other and try to detect the event based on that. Maybe gamma correction could help with the dark images. That's a good idea. I need to check that out. Sirs, welcome to the family. Thanks for joining us. I hope you've had a good evening. So we've went through a lot of stuff with this. Maybe I should look at what other data's out there. Or what other comments are out there. Oh, Camara has the same question as me. I'm not quite sure what's being asked here. With each video, there's a defined set of scoring intervals, giving the intervals of time over which 0 or more ground truth events might be annotated in that video. Oh, now I'm starting to understand why they have the different intervals. It's just based on occurrence. A prediction is only evaluated if it falls within a scoring interval. These scoring intervals are chosen to improve the fairness of the equation by, for instance, ignoring edge cases of ambiguous events. I need to think about this later. Hi, just discovered the channel. It's amazing. You do a great job. Thanks, sirs. Welcome. I want to call you Chris, but I know your name's not Chris. So, hey, sirs. Cersei Lannister, is that your name? Yeah, so I'm pretty excited with myself being able to pull off this deep sort run. I think that just running YOLO on this and seeing if anything can be done with just the training labels and the XY position of the data. Basically, you turn it into a tabular competition at that point, because you can extract out the location of the players, and maybe you just leave it to other people to post-process out the sideline people. But then, like, I'm assuming, like, based on where players are standing, the model may be able to learn, for instance, where a throw-in is. Because a player will be by the edge, right? And the same thing with events, right? It would be nice if our ball detection was a little bit better. I'm Cristobal, but call me just Chris. Okay, so you're Chris. You're kind of our Chris, right? So why is your name Circe? Why is your username Circe? That's throwing me off. How do we get a good detection of the ball? That's a good question. So I think the problem is that the resolution of this video is such that the ball is just going to be like, look at this. How would we, I know because I'm a human, because I'm a human and I saw the prior frames. Actually, if even as a human looking at this image, can you tell where the ball is? If you had just looked for the first time, it's incredibly hard. This ball looks like it's a dot within the D here. It could just be some of the text here on the back. But the pixels to identify the ball are so tough. When it's on the green field, though, it's pretty easy to detect. So I feel like, yes, the object detection could be improved drastically for the ball. That may be key in this competition. Citation needed? For what? What's going on here? That guy was getting in a fight with the goalie. So yeah, there's a lot going on here. Maybe like deep sort, doing it across frames. That's the thing though. Deep sort only, so the way that deep sort works, deep sort, not Kaggle. The way deep sort works is it takes the output of YOLO v5, or it takes the output of any object detector, and then you give it some threshold. So let's look up the GitHub of it. And there are manual ways you can do code up to do the same thing. But you give it stuff like the minimum confidence of the IOU. So you could set this really low maybe and it would detect the ball. Actually, we could actually run this. Let's run this. So I put the classes here as 0 and 32. That's because 32 is the sports ball and 0 is for a person. So if we did this, but just for 32 and ran it, it probably won't detect anything, but we could set like the YOLO thresholds to be very long. It also, deep sort does not work great when trying to detect something. Where's the output? Maybe it doesn't like this commented outline. Deep sort doesn't like when the object moves very quickly across the frames, because what deep sort is trying to do is identify, see here it finds the ball. It does find the ball here, then it loses it. But deep sort's trying to track that ball, and when it sees it move so drastically across frames, then it starts to think it's a brand new object. So that actually could be, let's turn off this crop field. Try it again. To identify the ball direction in which the players look is important. Ah, that's another thing. You could do like pose estimation or something. So I'm trying to see if it's detecting the ball at all. And it's just struggling. We can set the confidence threshold really low. Let's put it down really low and see what we get. There we go. So I wonder if we could set different confidence thresholds for different classes. Maybe that would be helpful. Because look, it's actually detecting the ball at least when it's still. with this low confidence threshold. When it's isolated and it's still. Now, one other thing we can edit here is deep sort. All right, so this builds the tracker. Now I'm remembering. This is in Data Shootout. I keep on forgetting the name. Deep sort in the configs. All right, so here we go. This is the deep sorting config. It takes 3 frames before it'll initiate, saying that it sees an object. Maybe we can make this 1. The max age we can make like this. Max IOU distance. So this means that like the previous frame should overlap the last frame. When the ball is moving quickly, this is not going to work. So we can make this large, but it's not going to work. Max overlap. I don't know why it's max overlap. Shouldn't be min. So this IOU can't be over 1 or else. Maybe this is Euclidean distance. Let's look up the deep sort. Let's look up tracker distance. Max IOU distance is set here. And then when it's using linear assignment, the cost max IOU distance, maybe this could be, let's try just 15. I don't know. Try something crazy to see if it. But what are the other configs? Oh yeah, max distance. That's what you were saying. I don't know if it's doing better or worse now. It's finding the ball a lot. You can also see the Kalman filter being applied because you saw there was like a 16 way over to the right. And then instead of being exactly on top of the ball, it slowly followed the ball. Yeah, see, it happened again. It had like a 35. So it's definitely working better now in tracking the ball when it's moving. It's really struggling there. This is a good example. The ball's moving a lot. So maybe I make this max distance 15. Let's see what this looks like. Maybe increase confidence. It's funny because I have this min confidence here, but I also have the min confidence in here. My confidence threshold. So I think this one being lower than the other. Yeah, so let's make this 0.2 here. It's tracking the ball a little bit. I mean, I think it's tracking, it's finding the ball better. Now here's the question. If I take this and I put back in finding people. If I put in finding people as well. Will it be able to deal with all that? Let's wait. Maybe this will work better for the people too because they move fast as well. Is it starting to lose the ball? X-Have, welcome to the family. Cheers to you. Cheers to you, man. Yeah, see, I think... Ooh, I'm starting to realize something else. So part of it too is there's an IOU threshold here. So when this object detection runs, it's actually finding like a bunch of, it's labeling, instead of labeling a person, it's probably having like 50 people being labeled on top of each other with slightly different boxes. And the non-max suppression will actually make that into like a single box for each person. But you also have an IOU threshold of the person and the soccer ball. So if the soccer ball is within the box of the person, it'll suppress the ball out, I think. So let's change this to be really low. Hello, ETSW. Welcome. We've had a fun stream so far. Let's see. So whenever this box for the soccer ball is within the box of a person, it's being suppressed out. I think that may be part of the issue. Because now if we look at the same clip that we just watched, we'll remove the 0 class. Yeah, it seems to be doing... Am I making this up? Or isn't it doing better about detecting the ball here? Maybe not. Maybe it's worse. Yeah, I can't tell. It actually doesn't look that bad there. Or doesn't look that much better when I remove the person class. Definitely running faster. So one thing to think about for this competition too, I don't know if this YOLO detection, object tracking will even be helpful in it, but it's pretty slow to do all this stuff. And to do all this stuff and to have it run on all the test videos will be tough to keep under 9 hours. And then probably run another model on top of that to run inference. So you very quickly get up against that 9-hour limit that Kaggle requires in order for this competition to be working. And you have a smaller GPU, I think. One last time, let's put on crop field and see how this looks. I also want to make this max IOU distance larger. And run our crop field. So this is like everything on that we've worked on. Cropping the field out. Hello, everyone. Oh, ETSW, you said that a while ago. And I already read that. All right, so this is like everything at once. Wait, crop field isn't working. Oh, that's because I have this here. Let's kill that. There we go. All right, so now it's not going to detect people in the sidelines. One thing that might want to do too, and this would involve diving deeper into the code, but actually figuring out which team the players are on. Because right now it just is doing a classification as a person, but you'd also find like the colors within the box. And this would probably be more important to do at the same time as you're running this inference while you have these images in memory, is to store the image of the average color within the player and maybe ignore greens. Whoa, did you see that when the ball was moving? Where is the ball right now? I don't even see it. Oh, there it is. 47. All right, cool. So we did a good bit of stuff tonight. I think I'm going to end it here. I got to travel for work tomorrow, which will be fun. But I thank all of you who came and joined me tonight. It was a lot of fun. I hope you had fun. Let me know in the chat, or let me know by joining our Discord. I can do exclamation Discord. If you enjoyed this stream, you can also check out my YouTube. Have you seen the machine learning Humble Bundle? Aren't Humble Bundles for video games? No, I haven't. Humble Bundles seem like just pay money for something you probably won't use. Tonight's stream was great. Thanks, MGX. So I also am promoting my YouTube. I'm considering maybe starting to put my streams on YouTube, but I'm a little bit worried about what that would be. This latest 100 prisoners problem one, I was really excited about. It didn't get that many views, or like the trends on it don't look like it's going to be very popular. But if you like riddles, if you love math riddles, you would like this one, because I basically took someone else's video that they did on this really amazing math riddle and I coded it up from scratch. But there's a special one. What's that mean, Data Basics? There's a special book in the bundle? All right, so let's find someone to raid. Twitch events. Where am I? I'm in a advertisement for some reason. Software and game development. Let's see who's coding. Python. Not many Python coders tonight. So let's go ahead. Actually, there's oh, look, someone's saving images. We gotta raid this guy. Operation Automate Podcast Uploads. Coding with Strangers. I like this username. I like what I'm seeing here on the screen. I like the type hints. I want to see what Data Basics is talking about. The Humble Bumble A to Z of machine learning. Oh, hey, I'm in this book. I mean, I just have like an interview in this that's a few pages, but it's cool to be on this. It's cool that that's a top video, or the top book, the first one that they show here. Thanks for sharing that, Data Basics. Now I know what you're talking about. All right, Coding with Strangers is definitely getting my raid tonight. I'm going to switch to this view and say thank you so much for joining tonight. I really appreciate you all. I hope we learned something tonight. I hope we inspired some curiosity. That's my goal here. And until next time, let's go ahead and get this raid going. I'm going to click on raid channel. And I will see you all soon. So make sure you stick around for Coding with Strangers and give them a lot of energy and a lot of positive vibes. And I will see you guys next time. Maybe I'm traveling for work, like I said, tomorrow. So maybe Wednesday. Maybe not. Check out, put on the alerts. That's how you'll see you next time I'm streaming. All right, see you guys. Have a good one.